see you all here. Actually, also physically and remote. It's great that these times are hopefully over pretty soon. I'm your host, Philipp Meyer. I'm working for Isovalent, and I've organized this event together with Puzzle ITC. Thanks for organizing it. They also do services and consulting for our product. And today we have 3 great speakers here. Priyanka Sharma, who is coincidentally in Zurich this week, so she agreed to talk today as well. We have Liz Rice here, my colleague from Isovalent and also chair of the CNCF Technical Oversight Committee. And Thomas Graf, CTO of Isovalent, creator of the Cilium project, and very newly appointed chair of the eBPF governing board. The event will approximately take 2 hours, and we will have Q&A at the end with all 3 speakers. And at the end, we'll have some drinks outside at this food truck. And with no further ado, I'll pass over to Priyanka.
Great. Thank you so much. Hello, everyone. Wow, this is new. It's been a while. This is my first speaking engagement in person since, well, the pandemic, and also since I took this role of General Manager of CNCF. So super special. Thank you to Liz and the rest of the team for inviting me. Let me just make sure I can see. Oh, I can see. OK, great. All right. Well, today I thought you're going to get some amazing technical talks from Liz as well as Thomas, right? So I'm not going to go in that direction. Instead, what I'll talk about is how the CNCF, or Cloud Native Computing Foundation, enables all these great technologists and all the technologies that they build to create an ecosystem that we're all a part of. So this is an intro into how the inner workings of CNCF. Some parts will be more interesting to someone, other parts for others. So think of it as a quick 101 course. And at the very end, I spend a little bit of time talking about what's the latest and greatest for us right now, which includes work with eBPF and Cilium. Oh, also, I have some stickers and fidget spinners that I bought, but I was late, as often happens with me. And so they're still in my backpack. After the talk, I'll put them out for folks to take if they like. All right, so CNCF. How many folks here know what CNCF is already? OK, awesome. So I am talking to an audience that will not think I'm talking total gibberish, so that's good. As you folks may know, our mission is to make cloud-native computing ubiquitous. Now, that may sound a little tautological because our name is Cloud Native Computing Foundation. So let's go through what we actually mean by that. So just to give a quick intro to those who may not know me, I'm the general manager of CNCF. What that means is everything's my responsibility and my problem, so it works out great. But no, what it really means is leading this foundation and helping and supporting the community, both from an enablement perspective and also from a financial viability perspective. So it is my job to make sure that we stay afloat and support all the projects out there year after year after year, which has been particularly interesting in the last year because we really depend on our events, which are the largest open source conferences in the world, to generate a bunch of revenue for the foundation. But we've still managed to do a really good job, and I'm really happy to say that the community came through to support each other in that whole time. Myself, I've been in tech my whole life, my whole career, but cloud native was something I joined in the early days in 2015, I think. I was a contributor to the Open Tracing project, which is recently being archived. It's the right thing, but it's like, oh, tears. So it was really like a lot of work that I put into that. So observability is something I really enjoy. So I've been involved with CNCF in the contributor capacity at first in 2015. Then over time, I moved to GitLab, which is a company that's all remote. And so I got used to actually working remote pre-pandemic, which really helped. And at GitLab, I got elected to be a member of the CNCF governing board. And that's where I really saw the inner workings of, excuse me, what we all kind of participate in as an ecosystem. And then I was approached to lead the foundation, and eventually it all worked out. I accepted the job offer pre-pandemic and started post-pandemic. So it was like, yay. But anywho, so that's me. I also spend time advising companies and startups as time permits, and I spend a way lot of time on Twitter. So if you ever want to reach out after this event, you can DM me there. My DMs are open, or just regular tweet at me, and I will definitely get back to you. And I really hope that we can start conversations here that continue beyond the event, because it's part of the reason why I'm here, to make new friends. So TLDR of what we're going to talk about today is just how CNCF helms what is the fastest growing open source community in the history of open source. That's all of us. So yay. We have largest, as I said, the largest open source conferences. We have member companies, close to 700, and we have 100+ open source projects in CNCF. I really believe that all this growth has happened because this foundation is different from pretty much any other in that we offer an end-to-end support system for everyone in the ecosystem, whether it's projects, contributors, members, and we try to keep up with the pace of innovation here by providing more and more programs. With all the work that's gone into this whole ecosystem, it has really become a scaffolding of the pandemic era. I think we really accelerated all the digital transformation and things like that because of what happened in the last year and a half, 2 years. And at this point, with 100 projects, 700 members, hundreds of thousands of contributors, I really believe that this is just the beginning, and cloud native is evolving. So you all already know what CNCF is. We host critical infrastructure components and bring together world's top developers, end users, vendors, all such people. As I said, over 125,000 contributors with so many lines of code, so many commits. All of that happens in the auspices of CNCF. As I said, the mission is to make cloud native computing ubiquitous. What does that mean? For that, we just need to look really quickly at history. If you think from how we went from virtualization to cloud native, at first there was the Sun Microsystems world, right, in 2000, where it's all real hardware. Then comes VMs and VMware and all of that, and changed the world in many ways. With AWS, the whole cloud and cloud provider, all that got started with as an infrastructure as a service. And things kept evolving over time. You have like a PaaS, then you have an open source IaaS, and it just keeps going until Docker really made containers mainstream. And that was really the beginning of cloud native. Because once containers became mainstream, Google eventually open sourced Kubernetes, which was container orchestration, as you all are aware. And that just created a new paradigm of software development, which we now call cloud native. So that is what we're talking about when we say we want to make cloud native computing ubiquitous. It's not just about making Kubernetes go everywhere or a particular project, but rather a way of building software which is about decomposable modular structure, segmenting applications into services, microservices often, then putting them in containers and then dynamically orchestrating them so that you have the best resource utilization. And all of this is important because it helps developers ship faster, resiliently. A key piece of supporting the ecosystem in this journey for us in making cloud native computing ubiquitous is providing an opinionated definition. And this is something that is out there. It's on our GitHub repos, available for anyone to use. And it's kind of a guiding light or a North Star in a world where often terms can get really mangled and used to describe completely different things. So what are the projects that are helping all of this happen? We all know Kubernetes, right? Is there anyone here who's not familiar with Kubernetes? It's totally OK. I can totally do a quick description. All right, we're all on the same page. So as you all know, Google created Kubernetes and then really initially did the lion's share of all the work. And then they donated it to CNCF. And a really good barometer of success is the fact that over the last 5 years, the amount of work Google does on Kubernetes, like the total amount, has increased, but relatively, their percentage contribution has shrunk from 80% to 75% of the work. And that's an excellent outcome for us, for Kubernetes, for Google, everybody, because it shows just how many people are have a vested interest in this project. Starting with Kubernetes, as I said, we've come a long way, close to 100 projects. There's 3 tiers, and Liz knows more about all of these projects than anyone as she chairs the TOC, or the Technical Oversight Committee, which makes the decisions to take projects like these in. But we have 3 categories: graduated, incubating, and sandbox. And it's a decreasing order of maturity from our perspective in CNCF. That is not to say that something in sandbox is not recommended for use. On the contrary, it's highly encouraged. It's just know that things are still taking shape in one way or another. It could be a super mature project, but the community might be new. Or it might be a new project that's still figuring things out. So that's where like a lot of fun innovation stuff is happening. And then by the time you hit graduated, you're at a point where we are putting our name behind these projects, telling you you can definitely use them in your production workloads, and you can move forward with confidence. And incubating projects, as apparent, are somewhere in the middle, but they're pretty far along as well. The sandbox is where a lot of the numbers for these projects come from. Every time the TOC sits and goes through the list that is up for vote, there's so many. And there's so much expansion of the cloud native point of view that you see happening in Sandbox. There's projects that are related to edge computing. There are projects related to security. There's projects related to multi-cloud, all kinds of things. It's super fun. I think you all are pretty aware that resource efficiency, resiliency, availability, all this stuff is why organizations are adopting CNCF projects. And then there's the flip side of why are people choosing us to host their projects in CNCF? It's a neutral home. There's an endorsement by the CNCF TOC. And you get all this engagement with end users, service providers. And we put a lot of time and energy from the staff and dollars into helping with documentation, security audits, PR services, case studies, all of that stuff. So suddenly, a project goes from the maintainers doing what they can to having a support staff, really, to help them really get the word out and be production ready in every sense of the word. And that's why I think we've been really popular. One of the key pieces, which maybe doesn't get talked about as often, but I think is really critical about the way CNCF operates, is our governance structure. So ultimately, we believe in end-user-driven open source. Let me unpack that a little bit. So are folks here familiar with what is an end user? I would like to hear something. Yes or no? Yeah? All those who know something, raise your hand. All right, so this is more mixed, right? Okay, so which is totally normal and expected because end user can mean a lot of things. If I'm using an iPhone, I'm an iPhone end user. But am I a cloud native end user? Well, in the context of cloud native, companies that utilize cloud native technologies are projects in their production workloads to build what they are building for their users. But they're not selling any cloud native services or products. They're end users. These are the people who are beneficiaries of these technologies existing. Now, of course, someone who creates cloud native technologies is very likely to also be using them. That's not what we're saying, that they're not users, but rather an end user is a special category of company or organization that is utilizing our tech but not monetizing it themselves. Great examples of these: Spotify is a company that I'm sure many of you are familiar with, or Zalando, or Audi or Daimler. These are all companies that they use technology. Every company is a technology company now, but they're not selling. And we believe in CNCF, are very critical knowing their feedback and catering to their needs is critical to the success of the projects in the foundation. And with that in mind, we have given end users an official role in CNCF. And this, by the way, is something brand new. This has really enabled these folks to come and have a voice and be a strong contender in the discussions of what is the right move for any technology. And as I was telling you about the governance structure, we have the governing board, which is the body that oversees all the, the budgetary, financial things, and works with us, the execs, on execution of things. Then there's the TOC, led by Liz. And then there's the end user community, which is an equal shareholder in all our conversations. As I mentioned, the governing board is like business oversight, budget decisions. So we talk a lot about like how much we're spending and where, and is that the right move for the community? And we host quarterly board meetings. It's a lot of fun. It's a lot of discussions. I lead those calls. Well, and soon it'll be in person, so that'll be kind of cool. But that's where all that happens. The TOC is where the technical vision of CNCF lives. And that's where engineers of real seniority with advanced level of professional experience come together and talk through what is the fate of projects wanting to come in and staying in CNCF. End user community basically coordinates and drives activities important to end users. We have a team member with a few folks supporting her who runs the end user community. Her name is Katie Gamanji. It used to be Cheryl Hung, who many of you may know, and now Katie is taking over the reins. She comes from an end user from financial services, so she has that, I would say, empathy, customer empathy, and she's been doing a great job. But we lead the EUC meets in developer groups that are not open to any vendors, that they can have clear, open conversations without fear of something being public to talk about what technologies work, what's not working, and support each other in the process. They also elect members to the TOC and provide feedback to projects and the ecosystem at large. There's a bunch of subgroups. I'm not going to go into that because we don't have time, but they're really cool. Marketing committee, technical advisory groups, and end user SIGs. Check them out. Really quickly, members. So this is another major stat. It's important to know this number because this tells you how many companies are putting money where their mouth is and supporting a foundation of software that they're using in most cases. So we have 650 plus members, and the number just keeps growing, and it includes every major worldwide cloud provider. We have the largest network of end user companies. So it's a pretty diverse group of people from everywhere around the world. There's large companies and startups. All kinds of people are part of the story. And then there's different kinds of members who are like Kubernetes certified service providers. So we created a program to make sure what the Kubernetes experience is stays standard across any offering out there, which has been part of the reason of Kubernetes success. And that is seen in the certified service providers, in the training partners, and also, in the certified Kubernetes conformance, which means if anyone has a distro, it's certified, it's going to be the same no matter which vendor you use. And that gives end users the power to be able to choose one vendor or the other and not be beholden to anybody. All of this great stuff, numbers are good. Why is it happening? It's because CNCF, as I said initially, is unique in that we host a lot of ecosystem programs to encourage the activity that is happening and make it bigger, better, and more inclusive. We're all a foundation of doers. The staff the staff that I lead, we all collaborate with the community to be creating new programs and materials every quarter, every month. And we just hop, skip, and jump to keep up with you all. And this is what results in this ever-growing Team Cloud Native. There's a bunch of staffed services and programs. So for projects and the community, there's an end-to-end experience. So you'll get technical documentation, developer relations. For graduated projects, there's security audits that are really critical. And then we also do things like marketing programs with online programs like Twitch shows or webinars or blog posts, All that is available to the community to participate in. Technology resources. This is something that comes up, that you folks are going big, and that's great, but this is getting overwhelming. And I totally agree. And that's where, again, the community has actually stepped up on their own, where there's a group that's formed called Business Value Subcommittee. It's part of the marketing group, and they are creating an ever-updated cloud-native glossary for folks who are coming new into the ecosystem to just start with the basics, learn that. There's also, as you know, the infamous CNCF landscape. And there's another group that's coming together, which is working on, it's called Cartographos. And they're working on demystifying the landscape with write-ups on how to navigate it. And all of this is community-driven, CNCF staff-enabled. So this stuff keeps growing. And I think the type of people who engage with cloud native keep growing. What started with as infrastructure engineers is now infrastructure engineers, back-end devs, product marketers, product people, developer relations, event staff. All kinds of people are coming in and doing their bit to demystify cloud native. There's the end user research that you may have heard of, which is our community of end users comes and provides an opinionated view of various products and open source projects in different technology verticals. So multi-cluster was one that happened recently. There's been database storage. There's another one coming up which is a little broad around DevSecOps. And those are really cool because that's end users telling you what they're trying out, what they're 100% adopting, what they're kind of looking at. So community programs. This applies to all of you. KubeCon, Cloud Native Con, as I said, the largest open source conference in the world. Registration is open, by the way, for virtual and in person. Who knows what's going to happen? But I do encourage, get started, book the virtual ticket if you don't know what's going to happen for, travel to the US. And if things change, you can change your ticket. I'm going to be there, barring any, mandates from the government. I'm really looking forward to it because I think after this, that's the next stage. So, yeah. Besides that, there's also Kubernetes Community Days. I highly encourage you all to look into that because various cities in the world are just going ahead and building their own. So there's been one in Mumbai. There was one Pan-Africa. There's one coming up for Brazil. There's one in every continent except Antarctica already scheduled. So y'all might as well do one in Zurich as well. And right now, those are virtual, but you can, you can pivot to in-person over time quickly. And then there's cloud native community groups, which are basically local meetup events that you just need to, if you go to this link over here, you'll see all that's available. And it's all virtual right now, slowly moving over to in-person. Trainings and certifications. Are there any folks here who've taken any of our certifications from CNCF, which is the Certified Kubernetes Admin, Certified Kubernetes App Dev, or the latest Certified Kubernetes Security Specialist? Good job. That's excellent. Now, I highly encourage folks to look into that just because it's, it's a very large growing community of people. It's a difficult exam, so it's hard to pass on the first try, but it really helps with job mobility, with just a refresher course for your own self, etc. And this is something we're putting a lot of investment into. We do a lot of scholarships. We do a lot of support for need-based help where people can't afford it, etc., etc. There's ambassador program, mentorships. There's a lot of resources. Because we've grown so big, this is one of the benefits of that, is that if you want help, it's definitely available. You just need to look a little or ask somebody. And maybe you don't need this help, right? Maybe you're already at a point in your career where you're kind of past it. But there are probably folks that you mentor that you know of who could really benefit from this, so I encourage you to spread the word. Everyone can contribute. So not only can you contribute to the projects, you can also join some of the working groups or technical advisory groups that serve under the TOC or under Kubernetes as SIGs. And there's so many options. So you should look at that if you're more interested in a technology vertical versus specific project. Telco industry, something that's taking up a lot of time and attention from my part these days. We have a CNF working group, which is Cloud Native Network Function Working Group, and a test suite that there's active collaboration happening on. If anyone wants to talk about that after this, I'd love to chat. And everything is open to all. There's so many things. There's the blogs, there's the groups like Cartographos that are demystifying the landscape. You can literally pitch a Twitch show. If you're into that, I encourage it. Just go for it. So lots to do, lots of options, open to all, some for contributors and members, and some for members only, which is to give them a little bit of boost through this ecosystem. Really quickly, people become members because they want to take an active role in supporting the growth and evolution of cloud native. What they get in return is often marketing amplification, brand awareness, community engagement, and thought leadership. There's a lot of details around this that I'll let you kind of look at your own pace if you're interested, or you could forward it to people in your companies who might be interested. So yeah, take a look. There's a ton of stuff. That's the thing with CNCF. We've grown a lot large, so there's lots of programs, lots to kind of go deep dive into, depending on what you're interested in. Lots of tiers, really looking for end users right now. So if you know end users who would like to be members or supporters, connect me. All that you can look at your own pace. But TLDR for why end users want to join is they get to participate in the community. They can hire better. They can optimize their own open source strategy. And frankly, they get a lot of cost savings because they're training devs much faster, hiring them much faster by being part of this ecosystem. So all that said, that was the 101 overview. And now I'll quickly go into, I actually don't know at all if I'm doing OK on time. It's fine. OK, cool. Great. But wrap up is just what's the latest, right? So today, 100 plus projects, 25,000 plus contributors representing 177 countries, basically the whole world. It's pretty great. And we welcome each and every person. So more and more and more. And there's a lot of effort into the diversity, equity, and inclusion here. So for instance, a parallel effort that I've kicked off is called the Inclusive Naming Initiative, where we are trying to remove exclusionary and harmful terminology from code, starting with the terms master and slave. And there's, it started as the movement started with actually the Prometheus folks. They were the ones who really kickstarted this idea with us. And then it's just been growing. Like the number of people showing up from the number of organizations is just amazing. And so now it's its own initiative within the Linux Foundation. But that's just one example of DEI being a key focus now, because we have the numbers. It's proof that there's so many who can participate, and we just need to bring people in. As I briefly mentioned, COVID-19 ushered in a new cloud-native world, right? We were talking about digital transformation as an aspiration for some companies pre-pandemic, and some were like not even interested. That's not the case anymore. All kinds of people have had to utilize technology and get comfortable with it. It's like restaurants are learning to take online orders. It's like we needed to all learn to work from home. It's like people developed mRNA technology vaccines that we all used, most of us. And then like contact tracing, all kinds, like lots of leaps of faith. And even just on the purely commercial side of things, like there are companies that have had to just shoot up. A great example is Peloton. They did a keynote at KubeCon, Cloud Native Con EU a few months ago. Literally, they moved to Kubernetes and hired majority of their cloud native development staff in the pandemic. And that's like so many developers. And they're not alone. There are so many more folks who have done that. A lot of them used cloud native, for example, if they were highly regulated industries and really needed to make sure security was front and center as people worked from home, and they used a lot of projects in CNCF to enable that journey. There was a talk by the government of Ireland when they were sharing at last KubeCon, where they shared about just how they used cloud native principles to develop their contact tracing app, which then they've shared with other countries around the world. So people have just moved fast, and that's great. And that's really put a surge in the CNCF and our world of cloud native. And I have some like brand names here that I put in of like companies from different parts of the world that have been utilizing cloud native technology very successfully in the last few years. During the pandemic era, because of all this momentum, we've had a major growth spike. Members have grown, contributors have grown, projects have grown, everything is up and to the right. And that's amazing, but it's also meant, quite frankly, that we all have needed to kind of support each other more as a community. Because I don't know about you, I feel like work doubled in the pandemic. It was just so much. It's like we're not traveling anymore, stuck to the computer, it's just go, go, go. And it's good, but it's also, we have to be resilient together and keep an eye out on how we sustain this growth over time. And all of this is leading to an expanded TAM, or total addressable market, for cloud native, right? What started as a foundation with one project, Kubernetes, which does container orchestration, has now really evolved, and it's evolving every day. We are running in different environments. We are spanning all kinds of areas. There's, as I was telling you, like edge, service meshes, WASM is getting interesting and connected to cloud native. AI, ML, like this whole ML ops thing, the number of startups that reach out to me for advice on that is just mind-blowing. The movement is on. And I think it's because, let me see, I didn't put a slide in there, but I think there's this rise of the cloud native X professional. All of you folks would be one of those, which is where you have a baseline of cloud native understanding, and then you're applying it to various industry verticals, various technology verticals, because this is becoming the scaffolding in the pandemic era. And so innovation is happening on top of it. And that's what's expanding our total addressable market in CNCF. I put this slide in just so you know what I am working on every day. So my key areas of effort right now, I'm putting a lot of energy into the telco and edge world. More so telco, edge is like kind of doing its own thing and doing a really good job. But the CNF working group, talking to all service providers, end users, all that. So that's something major. End user communities remains a top priority. For project sustainability, specifically something I'm working on is a thing called Cloud Native Credits Program that's going to be announced, fingers crossed, at KubeCon North America, which is we're bringing together cloud providers and CI credit providers, folks like that, to donate to CNCF so that we always have a bunch of resources that we can give to the projects out there, and the projects are always secure that they're going to have compute and they're going to have CI resources. And that is another layer of safety for CNCF projects, because this happens all the time where a benefactor company suddenly has a change in direction. They can't support a project anymore. With this effort, the hope is that kind of risk gets minimized. The programs for members and communities keep rising. Cloud Native TV is our Twitch show. Highly encourage you checking it out. We have Kubernetes Community Days. We have the hybrid KubeCon Cloud Native Cons. And these take a lot of energy, a lot of time and effort, but people seem to like it. As I mentioned, we're working on the inclusive naming initiative to bring inclusivity to the language that we use. And then I'm hiring all the time. So if you're interested in working on cloud native, a lot of the work we do is around program development for the community, whether it's for projects or members or for individual contributors. So it often takes like a developer relations type personality mixed in with the organizational structure to create and execute on programs. If you know anyone who'd be a good fit, definitely hit me up. And then finally, another cool thing that's happening, which you will hear a lot more about, is CNCF, eBPF, and all that jazz. This is an example, in my opinion, of our expanding TAM. And that's our collaboration with the eBPF Foundation, with Thomas, with Liz, in that capacity as well. eBPF is such a core technology. I'm sure I'm preaching to the choir here on that. Because of its licensing, because of the proximity to the Linux kernel, eBPF was best suited for its own foundation within the LF. And it's up and running, and we're so happy for that. Because now we have an entity we can collaborate with really easily. And that's what we've been doing. And what you're seeing and happen in the CNCF side is that eBPF-based projects that impact the user space, right? There's Pixie, which is in the sandbox. There's Falco, which is graduating incubation. And then soon, fingers crossed, it's possible that Cilium will be joining and finding a happy home in CNCF. And that's so exciting. We all know the impact Cilium has had on so many developers' lives everywhere. It's such a well-loved project, so robust, and it's applied and it's really exciting because this is the eBPF-based innovation on cloud native. It's like the cloud native X professional, the cloud native X, Cilium eBPF world is now becoming more real as this is happening. From our end, we intend to support eBPF and related cloud native code with security audits, anything we can support the sister foundation with, because it's in everybody's best interest. And it just works out so well because we're in the larger Linux Foundation umbrella, and we have really close ties. Thomas is right here. And at the same time, the user-facing stuff like Cilium, Pixie, all these can come into CNCF and be deployed really quickly by companies and get results. So that is one of the major areas that is seeing a lot of momentum. And I have to say, having Liz in the CNCF as such a core participant has, I think, expedited this. And that makes me super, super happy. It's folks like that, like they bring in all kinds of cool new verticals, edges to cloud native. And that's what keeps us ticking. Just so you know, we are hosting a Cloud Native eBPF Day at KubeCon Cloud Native Con. Schedule will be announced like in 2 days, so pretty soon. I've put the link there. You can go check it out. As with everything that's happening with KubeCon Cloud Native Con, this will be virtual as well as in person. So if you can't go, you can totally attend. And you'll see the schedule in a couple of days, and it should be pretty exciting. Finally, to take it back to the high level, our 5-year vision is to build sustainable ecosystems for cloud-native software, for containers, and beyond. I think it's become pretty obvious that we're going way beyond containers at this point. And we want to be the end-user-driven open source foundation, with majority, fingers crossed, members being end-user orgs. You can check out our OKRs that are available publicly, and this is something new we've been doing, and we're going to continue to do every year. And I hope if you ever have feedback, if you ever have thoughts, please just reach out. I'm always available. My team is always available. We're part of the community just like you, and we want to collaborate. With all that said, thank you so much for listening to me. I hope you have a great rest of the day.
Thank you so much, Priyanka.
Yes.
So next up is Liz. She's our Chief Open Source Officer at Isovalent and Chair of the Technical Oversight Committee of the CNCF. And she'll tell you why eBPF has superpowers in connectivity, networking, and observability.
Thank you. Hi, everyone.
Hey!
Give me a round of applause. Come on, let's do that. Thank you. All right, so I am Chief Open Source Officer at Isovalent, and I joined Isovalent in March of this year. And I joined Isovalent because it is the company with the most experts in eBPF. And eBPF is a technology that I've been excited about for quite a while now, quite a few years. And it seemed like the natural place to come if I wanted to, learn more about it and make some more moves in the world of eBPF. So what I'm hoping to do today is to share some of the reasons why I think eBPF is so compelling and so exciting, particularly in the world of cloud native. As Priyanka says, I'm also the chair of the Technical Oversight Committee for the CNCF, and that gives me a really nice perspective over lots of different technologies and what people are excited about across a broad spectrum of areas of innovation. And November last year, I guess, KubeCon, I made some predictions on behalf of the TOC. It wasn't just me, it was the TOC collectively. One of those predictions was that eBPF would become significant in the cloud native landscape. And I think the fact that Cilium is applying to join, I'm pretty confident that it will be accepted in probably the next few weeks. I think that speaks to the maturity of eBPF, and it's one of the reasons why I'm involved in this technology. So, how many of you here, put your hands up if you know what eBPF is? Okay, we've got quite a few people, and not all of them are my colleagues who've raised their hands there. So, eBPF stands for Extended Barclay Packet Filter. That is not terribly helpful for those of you who don't know what eBPF is. What it really is a way of making the kernel programmable. It allows us to write custom code and run it within the kernel. We don't have to reboot our machines. We don't have to write kernel modules. We can dynamically load custom programs and run them within the kernel. So how does that work? How many of you write code or have ever written code? Raise your hands. Almost everyone. Excellent. So you'll know that when you're writing application code, you're writing in user space. And user space applications typically can't do very much on their own. They have to ask for assistance from the kernel. And the kernel will do things on behalf of user space applications. When we're talking about eBPF applications, we'll typically have some user space code that will load an eBPF program into the kernel and attach that program to some kind of event. An event might be a network packet arriving or a particular function being called, either in user space or in the kernel. Or it could be a trace point or a security hook inside the kernel. So whenever that event happens, the eBPF program that we've associated with that event gets run. And then the user space code and the kernel program can communicate with each other in limited and special ways using a thing called eBPF maps. So I've got a little video here of the hello world of eBPF. And I'm starting off here with the C code that we're going to run in the kernel. And I'm just really literally writing hello Zurich into a trace. Well, I'm using a trace function in BPF. And I'm going to attach it to execve, which is a system call that gets called every time a new executable's run. And then this is the user space code that reads the kernel object file, loads it, finds the hello program that I want to run, attaches it to that execve system call. And then it's also going to pull the tracing messages and print them to screen. So when I make that, I've got two things I need to make. There's the kernel, the object file that's going to run in the kernel, and there's a Go program, that code that you can see there in user space I've written in Go. When I run that user space program, I have to have the privileges to run BPF. So I'm going to have to run that as root, otherwise I'll get permission denied. And when I run that, I can see lots of instances of my hello Zurich being triggered because there's lots of executables running on this machine due to my editor. One thing to note that we will come back to is the fact that we can see some context around that hello Zurich. We can see the name of the executable and the process ID, for example. So when the eBPF program in the kernel is being triggered, we have some context, which we will come back to. So how can we use eBPF beyond Hello World? How can we make it useful in the world of cloud native, in Kubernetes? When we run applications in Kubernetes, they're containerized and they're grouped into pods. Doesn't matter how many containers we have, how many pods we have, each virtual machine or machine that we're running on has one kernel. So all of our containerized applications on that machine, they're all sharing the same kernel. And our pods running user space applications can't do very much in user space without the assistance of the kernel. Every time they want to open a network connection, send a packet, read or write to a file, create another container, all of these things require kernel involvement. And it's just that one kernel on that virtual machine for all of those pods. So the kernel is aware of everything that's happening on that machine. And if we write eBPF programs and load them into the kernel, they can be aware of what's happening everywhere across that machine. So let's take an example thinking about networking. This is an example from Cilium, where it might be a little bit small to read, but what we can see at the top is a view of the flows between different services in a Kubernetes cluster. And in the bottom half, we can see individual flows, individual communications, which we can associate with the source and destination pods and services. We can do that because Cilium's acting as the CNI, the networking component in Kubernetes. So it's responsible for connecting together these different services. It knows what the context is of each of these services and what pods are involved and everything about those services. And every time a network packet flows, we can have eBPF programs running that are aware of that context. They're aware of those Kubernetes services that are involved. So we've got this pretty powerful view of not only are we connecting together those services, but we can observe the network connectivity between those services. And we can do this because eBPF has this view across the entire machine. It's aware of everything, all of the network connectivity that's happening across the machine, and with Cilium running on multiple machines in a cluster, or even multiple clusters, we can be fully aware of all of the network connectivity. And this is actually a really efficient way of doing networking. Normally, in a Kubernetes environment, we have the containerized application, and it has its own network namespace in that container. And there's also a network namespace on the host. So every time a packet arrives on that machine and that's destined for a pod, traditionally, it would have to be routed through the networking stack on the host, goes to the virtual Ethernet connection to the pod, which from a networking perspective, that Ethernet connection looks just like a regular Ethernet connection to a different machine. And then the packet would have to traverse the networking stack inside the pod as well. So that doesn't look super efficient, and it's something that we can bypass with eBPF. Because Cilium has been responsible for connecting together all those networking endpoints, it knows, oh, this packet is destined for a pod. Well, I can just send it straight there. I am aware of the IP address. I'm aware of the MAC address. I'm aware of the pod that this packet is intended for. So I can just send it straight there without going through the whole networking stack on the host. And we did some benchmarking. I say we, my colleagues did some benchmarking. And we get things like this really cool flame graph where we can see a packet arriving, spending a bit of time in that eBPF networking stack on the host, and then traversing into the pod where it goes into the pod's networking stack. So the networking stack associated with the container namespace for that pod. I think you can kind of tell from that the amount of time on the host side is quite a lot smaller than on the pod side. And this kind of, if we look at request response time, it transpires to be true. that it is faster to do networking using eBPF than with traditional IP tables approach. There's a ton more information about these benchmarks and exactly how we did the testing on a blog on the Cilium site. You'll find it if you look for CNI benchmark Cilium, I'm sure. The blue line on this graph is host-to-host networking. And the red and orange bars are eBPF-based networking. One of them is Cilium, one of them is Calico. The yellow and green are Cilium and Calico operating in non-eBPF mode. And the takeaway here is that you can run networking nearly as fast between containers using eBPF. It's almost as fast as direct host-to-host networking, which is pretty incredible because we can bypass, essentially we can bypass one of two stacks on each machine. So yeah, check out the benchmarks for more detail on exactly what that means. But the key point here is eBPF is efficient, and particularly for networking, it's really efficient. So eBPF apps, as we've discussed, have this view of everything that's happening across the entire machine. And there's a really cool corollary to that, which is that you don't have to change your application or change the configuration of your application to take advantage of eBPF, because it's running in the kernel, and the kernel has the view of everything that's happening on that host. Nathan Leclerc did this really cool little cartoon, essentially talking about how most observability and security tooling in Kubernetes these days uses sidecars. And perhaps eBPF is going to turn out to be a better approach for the things that we're currently doing in the cloud-native world using sidecars. So let me explain that a bit further. When we create a sidecar, in the sidecar model, we have our pod with our application containers, and we have to inject a sidecar container into that pod. If the sidecar isn't there, we don't have observability or security or whatever the sidecar functionality is. The sidecar has to be in the pod to be able to get access to whatever's happening inside that pod. And in order to get the sidecar there, we need some YAML definition to tell Kubernetes, when you create this pod, you need to create not just the application containers, but also this sidecar container. So there's got to be this YAML definition somewhere. You could theoretically do that manually. Usually it's going to be automated. Either there's going to be some part of your CI/CD pipeline that takes your YAML definitions and modifies them to add this sidecar. Or quite often, applications will inject the sidecar during admission control. There'll be a webhook that will take your YAML definition and add in the sidecar container. But what if that goes wrong? What if somehow the sidecar is misconfigured, or somehow someone runs an application but they bypass the normal CI/CD process? If the sidecar isn't there, you're not aware of what's happening inside that pod. You could have a mixture of pods, some of which have got the sidecar instrumentation and some of which don't. There's kind of no guarantees in the sidecar model. If we use eBPF, all of the instrumentation is in the kernel. We don't need to make any changes to our pod. We don't have to have any kind of configuration change in order to instrument that pod, because our eBPF program is hooked into the kernel and has full visibility across all of the pods. And that's huge. It's huge from a ease of use point of view, because you can have your eBPF-based tooling that's going to load those eBPF hooks for you. And it's huge from a security point of view because it's going to be a heck of a lot harder to deploy something without its associated instrumentation. So there's quite a few projects in the cloud-native world taking advantage of eBPF. A few that we should mention that are featured in the CNCF landscape, or soon will be. Falco. Falco uses eBPF to spot security events, so things that look like malicious or suspicious behavior. And then it will alert you to those events. Tracy is a similar project to Falco, but a bit lighter weight. And Falco looks at system calls. Tracy will look at some other security event hooks called LSM hooks, as well as system calls. Cilium, of course, eBPF-based networking, which Thomas is going to tell us a lot more about shortly. And Pixie, which is from New Relic. Priyanka mentioned it. It's in the sandbox and is looking at using eBPF based on BCC to provide some insight into how your application's performing. So there's a range of different projects, all really looking at connectivity, observability, security. And those are three areas that eBPF is in an amazing position. It's an amazing technology to leverage for those three areas. And this is something that brings all of those three things together, this idea of using context awareness to provide security observability. So you remember when I showed you my Hello World program and we could see the process ID and the name of the executable. So we had that context for our eBPF program. And in this screenshot, we're looking at network flows in Cilium, tying those together with that process context and the Kubernetes awareness that we saw in the network flows. So we can see a pod which is running some executables, and that executable is making some network connections. And in this example, the network connections look completely reasonable. We've got Elasticsearch and the Twitter API. Those look like perfectly reasonable endpoints for a process to be connecting to. But imagine if one of those endpoints was a cryptocurrency miner or the command and control center for some malicious activity. You'd be able to not only see the connectivity to that endpoint, but you can also trace it back to exactly which executable, in which container, in which pod, in which namespace, in which cluster made that network connection or received that network connection. And that kind of forensic visibility is really powerful and useful for figuring out what's gone wrong in the event of some kind of security compromise. So eBPF is giving us the networking capability, it's giving us the observability capability, and it's giving us all this security forensics. So eBPF is making the kernel programmable. And so far, I've only really talked about Linux. And Linux is the operating system that most of us are using on a day-to-day basis when we're talking about cloud native. But apparently it's not the only operating system out there. There is, in fact, something called Windows, I'm told. And amazingly, Microsoft are bringing eBPF to Windows as well as Linux. And at first glance, that sounds kind of crazy because you think, but these are programs running in the Linux kernel, and they're referring to Linux data structures, and how on earth can that work? Conceptually, a lot of things in Windows and Linux and any other operating system, particularly if we're talking about networking, the concepts are pretty similar. If we think about a networking stack, it doesn't matter whether you're running on Linux or Windows or iOS. You've you might be having a TCP over IP, over Ethernet networking stack. There's going to be a lot in common across those operating systems. And that gives me a good mental model for thinking about how it makes sense for eBPF to run in different operating systems. There will be differences. You can't have an eBPF program that's looking at the specific kernel structure used on Linux and have that work. There won't necessarily be an identical structure in Windows, but there probably will be something similar. And the work that's going on in this eBPF on Windows project is very much intended to be as close as possible and to share as much as possible with the Linux world. So, for example, they've been reusing some of the existing eBPF verifiers to check that eBPF code is safe to run. We have to verify eBPF code before we run it because you really do not want your kernel dereferencing a null pointer, for example. Crashes in the kernel are bad. So, eBPF is not just for Linux. eBPF is coming to an operating system near you. As I said, I've been so excited about this technology that I've moved to the company that specializes in it, and I hope that that speaks volumes about the confidence that I have in this technology. Last week, we had an amazing online event called the eBPF Summit. Did anybody watch any of that? Anybody? I see a few hands. Yes. So we had tons of really great content from all sorts of different people who are innovating in eBPF, people who are using eBPF, lots of different perspectives on different projects and different ways of applying eBPF. So do check out the summit. You'll find all the links on ebpf.io. So with that, I hope that's given you an insight into why I think eBPF is exciting. And I think next up, Thomas will tell you more about Cilium. Thank you very much.
Thank you so much, Liz. Yes, next up is Thomas, CTO of Isovalent and creator of Cilium, and he'll tell you how Cilium leverages eBPF.
Dank u wel. Hoi zusammen. Freut mich, euch alle zu sehen. For those of you who didn't understand a thing, this is one of the rare opportunities where I get to speak my native language. I'm originally from Switzerland, nearby Zurich. Maybe 1 out of 100 speaking opportunities I actually get to speak a bit of Swiss German, so I always want to take it. So first of all, before I start off, I want to thank Puzzle IDC for co-organizing this today with us. I think it has been great to also have Priyanka, where is she? Back there. Definitely say hi to her. She's very, very approachable. She would love to speak with you and learn from you. I'm Thomas. I'm co-founder of Isovalent, one of the co-creators of Cilium. I didn't write every single line of code myself. I had a little bit of help as well. These days, I'm doing a bit of less coding and more what a CTO or co-founder does. I love working with, or the reason why I've created a company was to get a chance to work with people like Liz. It's a dream of every founder to be able to hire people like this. It's been incredible, not only from a perspective of creating the company and creating the project, but also creating a movement with eBPF that is now changing the industry. And that's what I want to talk about today, with practical examples in terms of Cilium, but also maybe giving you a bit of insight why I believe eBPF will change a lot in infrastructure. When I talk about the world, when I talk about the industry, I've always been involved in networking, security, in computing infrastructure. That's my little world. Let's see if we can get the slide. Yes, here we go. So Isovalent, who are we? I'll only have one single slide on this. We are a startup that is Zurich and Mountain View based. So we have roots in Zurich because of me, and my co-founder Dan Wendland is kind of heading up the US-based entity. We all have deep experience in Linux, in open source. Many of us have been Linux kernel developers for many, many years. I've been a kernel developer for 15 years. We know open source, we know networking. We have gone through the networking eras during the physical age, like with servers, plugging in cables during the virtualization age, virtual switches. Many of us have worked on Open vSwitch, that is, for example, driving OpenShift today, and so on. So we have been doing this for a long time, and we believe that eBPF is the technology that will up-level us to the next generation. Isovalent Cilium, just to make the difference very, very clear. So Cilium and eBPF, those are open source projects. Cilium, as Priyanka mentioned, is on its way into the CNCF. We believe that's the perfect fit for us. Cilium is deeply cloud-native focused and solves end-user problems for the cloud-native space. eBPF is an overall technology that is wider. Liz just talked about eBPF being ported to Windows. There is eBPF ports back to BSD, which is kind of the original root of BPF, the classic version of it. So for that reason, we have decided to create a foundation for eBPF itself, because eBPF applies not only to the cloud-native space. So there are applications of eBPF that are not related to cloud-native at all. How many of you have an Android phone? Great. So maybe if you have looked at the data statistics, like how much network traffic one of the apps is doing, eBPF is being used on your Android phone to account for that data. How many of you are still using Facebook? That's only one hand. Every single packet into a Facebook data center is being handled by an eBPF program from a load balancing perspective, from a DDoS mitigation perspective. How many of you are watching Netflix? Many more hands. Whenever Netflix has a performance issue, one of the Netflix engineers or many Netflix engineers will use eBPF to do performance troubleshooting. You will find, if you search for this, you will find many blog posts by Brandon Gregg showcasing how to do this. So eBPF is very broad. So that's Cilium and eBPF, and we will deep dive on Cilium today. And then there's Isovalent, company created by the co-creators and founders of Cilium. By now, Cilium is obviously bigger than our company. We're still, similar to how Priyanka mentioned this with Google and Kubernetes, we're still pulling a lot of the weight. But we have more and more external contributors coming in and taking on more of the load, how it should be. Also, why we are moving into the CNCF, we're now at the stage where we want a diversity. Cilium is well underway. We want a diversity of many shoulders carrying the weight. All right, well, this is the first intro slide. We'll do deeper dives into all of them. Cilium roughly does networking, security, and observability. Not a surprise. These are the things that eBPF is good at. So whatever eBPF is good at, Cilium provides, essentially. What is special about Cilium is Cilium has been created from day one with eBPF in mind. In fact, first couple of years we have spent evolving eBPF to the point that we can actually build Cilium. So Cilium has been created, the first line of code of Cilium has been created with the assumption in mind that eBPF will change the world. How do we provide networking? How do we provide security? How do we provide observability with eBPF with that in mind? So Liz mentioned this already, so I'm not going to go into details here. Nutshell, eBPF allows us to run code on some event in the kernel. This example shows an eBPF program being run when a system call is being invoked. This is how, and this is exactly what Liz did in her Hello World demo. We can run some code to, for example, extract some visibility, whether that's a print K to a console or whether that's extracting some observability data. But why is that so magical? That doesn't really make sense yet. Like, why is that industry changing? So let me talk about that a little bit. So I have this little comic here. My world, prior to eBPF, was working as a kernel developer for Red Hat. And I was getting feature requests, or our entire group was getting feature requests. Hey, I need this feature in the kernel. I want to observe my application in a certain way. The kernel is not capable of doing this. Can you help me add this feature to the Linux kernel? And myself or somebody else will usually come back, sure, it's going to be hard, but we will try. And it would then take me probably like roughly a year or so to actually get that change into the Linux kernel. Because guess what? You have to convince everybody else in the kernel community that this change is very critical. Everybody should be good, but this is highly needed, and you should be fine with it as well. And you should be willing to pay the cost for that as well, because every change in software imposes cost as well, right? Great. So let's assume I have been successful. After a year, a new Linux kernel version comes out with this new feature. But guess what? That's not enough, because most of you, maybe all of you, consume Linux as part of a Linux kernel or a Linux distribution. And the Linux distribution ships a particular version of the kernel. By the time this new upstream kernel version that includes this new feature hits a distribution, maybe 5 years have passed, maybe 2 years, maybe 5 years, depending on what Linux distribution you are using. This made the operating system, this made the Linux kernel a not so ideal place for innovation. Because guess what? You have to predict 5 years ahead. What will users need in 5 years? Because it will take so long to get your kernel change into the hands of users. So what have we seen? We have seen innovation outside of the kernel. We have seen user space networking. We're seeing sidecar-based service meshes. One reason for that is because it's a lot easier to change a proxy, a network proxy, than it is to change the kernel. That's been the major reason why there's been not a lot of innovation in the Linux kernel. The original thought of having Linux kernel modules to fuel this innovation didn't really work because loading kernel modules is insecure. It might actually crash your kernel. eBPF changes this. So let's look at how this all looks in eBPF. Same example, application developer comes back, hey, I want my observability feature. Now, it doesn't have to be a kernel developer responding. It can be an eBPF developer responding, saying, oh, cool, the kernel doesn't know how to do this. Let me write an eBPF program to fulfill your dream of observing your application. And a couple of days later, the eBPF developer can come back and say, hey, here is your eBPF program. You can try it out. Give me feedback. And then a cycle of innovation can begin. And we're changing the game in terms of going from years to delivering something to an application developers to days. That's why the industry, more and more of the industry, is incredibly excited about eBPF, because it is allowing us to take the high ground of the Linux kernel where we have all of the visibility, we can see everything, we have all of the control, we can control everything, we can even destroy hardware if we want to in the kernel. We can have all of this power, but we can innovate again, right? That is why eBPF is truly changing. That's also the difference to other approaches or other programming languages, for example, WebAssembly. eBPF, what is special about eBPF, it is operating system specific. So it's not a general purpose language that you would, for example, load into your browser. It has been designed to run and extend at the operating system level. So while it is totally okay to compare something like WASM and eBPF, they're conceptually similar in enabling innovation. eBPF is special because it is allowing this at the operating system level. This is how the overall eBPF landscape looks like, and this is what we maintain as the eBPF foundation. There is a lower portion, which is the eBPF runtime. That's what's actually running in the kernel. When Liz just mentioned that eBPF is being ported to Windows, that's this portion, like the actual kernel operating system level. This is where the verifier sits that will decide whether a program is safe to run. This is where things like maps and data structures and helpers and all of the low-level details actually exist. The kernel then exposes an API that eBPF developers can use. But that's a very, very, very low-level API. It's been designed for kernel developers, right? Remember, the reason why we created eBPF was to create innovation again. It's still the same people creating this code. It might be a little bit easier to write eBPF code compared to native kernel code, but it's still a very, very low-level API. That's why there is SDKs and then application projects on top of that. So the SDKs and the libraries, they will bind the eBPF layer to a higher level languages such as Python, Golang, C++, Rust. There's a growing variety, a growing set of libraries that will abstract this one level. And then even more important are the eBPF projects on top. These are the end user facing projects. Like if you want to have networking, observability, and security using eBPF, you can consume Cilium directly. You don't need to even know how eBPF works. If you want to, for example, have syscall visibility, syscall enforcement, you might want to use Falco. If you want to have application tracing capabilities, you might want to use BCC or BPF trace. These are the projects that sit on top. These are the projects that are consumed by the actual end users. All right, we already talked about this a little bit. We have created the eBPF Foundation a couple of weeks ago, and you can see Isovalent among the giants. The companies here, except for Microsoft, are basically the companies who have been employing and driving eBPF forward over the last 7 years. eBPF has been created in 2014. Isovalent and Facebook will still co-maintain eBPF. Then Microsoft joined in because of the port to the Windows operating system. The goal of the eBPF Foundation is to foster the technology in general and to provide the landscape and make sure that all projects have access to the resources, very much sharing the same ideas that Priyanka mentioned in her talk as well. So let's dive a little bit into Cilium so we can see how does the power of eBPF, how does that translate to something that an end user, all of you, can actually consume? What does that actually change for you? And we will go into what we call the cloud native networking journey. So let's go through this together, and maybe you will find yourself on this path. Typically, when we see end users consume a technology like Cilium, we see 3 different stages. And this is a bit Kubernetes specific, but most of this actually applies to a non-Kubernetes environment as well. But we have a stage 1 where it is all about getting Kubernetes up and running. At this stage, you care about basic connectivity. You may not care about security yet. If you care about security, you will probably care about configuration security. Let's make sure that we're not by accident exposing the dashboard to the whole world, right? That's kind of the Tesla moment, right? You might care about image scanning. You might care about like more static security things. And then in stage 2, this is where typically multiple tenants, so multiple users start using a Kubernetes cluster, or you have very sensitive applications. That's usually when you start caring about network security, network policy, zero trust, least privilege, you might want to encrypt, and so on. This is where Cilium starts to really shine, as we will learn later on. So this second stage, when you start caring about segmentation and so on, these are features that eBPF and Cilium can provide really, really well. This is also the stage where you might care about application SLAs. You might want to observe and monitor your application. Is my app still up? What's the P99 latency of my app? How many 5xx HTTP return codes is my application delivering back? These are topics and values that a service mesh or Cilium can provide. You might want to care about scale, or you might need to care about scale at this point. You might be running multiple clusters, many more services. Again, this is where Cilium can come in and provide a more efficient services implementation. And then we go all the way into stage number 3, where you go into the really advanced topics. And typically, this is when you fully embrace the microservices architecture. You split everything across, and you're running many services, maybe across multiple cloud providers, maybe across cloud and on-prem, and so on. And topics like multi-cluster, topic like external workloads come into play, things like securing your CI/CD pipeline. And believe it, BPF can play a role there as well. So on this landscape or on this journey, how many of you consider yourself like still in stage 1? Who is in stage 2? Like sensitive workloads, yes? Who is like all the way into stage 3 at this point? Fully Microserve. Very few. It's actually very representative. Most have not reached this stage number 3. It might appear like everybody's running this highly distributed microservices architecture yet. I think the majority is right now in stage 2, or just migrated from stage 1 to stage 2. At the same time, we're actually seeing a massive a massive need to, instead of just going full speed into stage 3, we're seeing a massive need of how can I integrate my external workloads, my existing workloads, maybe my set of virtual machines or my heavy database that is still running on a metal server, how can I integrate that into my cloud native environment? So that's actually probably the more likely next step for you. Let's look a bit into the features that Cilium can provide, and we will look at networking, security, and then observability. If you look at the networking layer, the most obvious answer, like what most people know Cilium as, is Cilium is a CNI. That's the networking layer of Kubernetes. It is highly efficient at doing so, and for the networking folks here in the room, it can do native routing, it can do overlays, it can do IPv4, IPv6, it can even translate between IPv4 and IPv6. It can do many things. It can even talk BGP if you want. It can directly integrate with the cloud provider SDN. So if, for example, you're running in Google Cloud, you can use the Google Cloud SDN natively, or you can still run overlay. That you have lots and lots of choices to create your most efficient networking layer. Then very important, we are able to provide a identity-based network policy implementation. It's going a little bit into security already, but it's still in the networking bucket overall. This is all about segmentation. Who can talk to whom? Can my sensitive application talk to the dashboard? No, it probably shouldn't. So we need to create segmentation. We're doing this with an identity-based approach. So instead of basing it off IPs and ports, which is kind of the old world, we are creating service identities and doing enforcement based on that. That's not just leading to a better security model, it also gives you better visibility because you want to know about service names, you don't want to know about container IPs, which are constantly changing. We have a proxy-free multi-cluster implementation. So as you grow, you will probably hit the natural scale limit of a cluster at some point, or you might have a multi-cloud strategy, or you might run clusters in different regions or different ACs and so on. And at some point, you want to connect the clusters together. Cilium can do so by kind of weaving a mesh purely from a networking perspective. So no sidecar or layer 4 proxies needed at all. It creates a universal data plane below all clusters that all of your pods can communicate with each other. We have a high performance load balancing implementation as a Q-proxy replacement. Q-proxy is the component that implements Kubernetes services, but we can also implement north-south load balancing as well. So if you're looking for how do I load balance my network packets into the cluster, we can take care of that with a maglev-based implementation. Very exciting. It's the same technology that Google and Facebook are using at high scale. Maybe you don't need it quite at that scale, but it actually gives you HA from a load balancing perspective, and that's equally as important no matter whether you're running 3 load balancers or 10,000. If one load balancer dies, you don't want the connections just to fail. You want them to fail over to another load balancer, and maglev can do that. So even if you're not running at Facebook or Google scale, this is still important for you. We have very efficient in-kernel transparent encryption. For example, if you have a compliance requirement that you need to encrypt everything in transit, it's simply a matter of like flipping a switch, and eBPF together with either IPsec or WireGuard can encrypt all of the traffic. What's fascinating about this is that it's not limited to just the endpoints that Cilium maintains. It can also fully embed a mesh that encrypts everything from any node to any other node where Cilium is running on. So even if you have things like host networking pods or you have just native Linux processes, Cilium can still encrypt that traffic as well, as long as the traffic is going to the other node where Cilium is running on as well. This is a big difference to running a full-blown service mesh with mutual TLS. That will only work if you actually have the sidecar on both sides. As soon as one side is not sidecar enabled, the transparent encryption is just completely off. So there's definitely a benefit of not relying on sidecar proxies. And then the last piece, non-Kubernetes external workloads. Cilium in the last version has become capable of running on a virtual machine inside of it or on a metal server, which means that you can now connect your external workloads, could be, for example, an existing database, with your cloud native environment. And your database will then become visible in the Kubernetes cluster as if it were running as a Kubernetes pod. So you can access the Kubernetes DNS, you have the visibility, you can enforce network policies, and so on. So that's a networking piece. There's already a lot that you can do from a networking perspective. All of this is pretty much in stage 2. Actually, let's go here. Yeah, so I picked one example here I think that's interesting that shows the difference between IP tables, which I've spent many years on working as well, and eBPF. So IP tables is the default implementation of kubeproxy. If you're not changing anything, you're getting an IP tables based kubeproxy implementation. I'm assuming in a couple of years that will change, and it will be either Cilium or an eBPF based one. That's based on a linear list of rules. So the more services you are defining, the more services you run, the longer this list gets. And every single network packet for every new connection, it has to go through this entire list and check, is it this service, is it this service, and so on. So the more services you run, the longer it will take to do a load balancing decision. eBPF can do per CPU hash tables. The cost is always the same, no matter whether you're running. And for all the software engineers out there, the O notation will make sense to you. The lookup speed is basically constant. And that's allowing Cilium to scale. It's actually fascinating that the cost of this is already visible if you're running 1,000 services. And that's not that much. You can already see the latency go up. And worst of all, it's actually not constant. It's the worst case latency that gets worse. If you're lucky, it will hit the first rule in the list. And if you're unlucky, it will hit the last rule in the list. So your users might get great latency, and then the next user gets horrible latency, and that's really hard to track down. So you want that constant lookup and load balancing decision. We have amazing security functionality in Cilium. Liz, and I will deep dive into this, already mentioned the process and network visibility combined. So let's mentally take a note. The next slide will deep dive into that. We have a lot of additional visibility that we can extract. For example, we can introspect all the TLS connections, all the TLS handshakes that are ongoing, and actually provide you compliance data. Am I using FIPS compliant SSL certificates or ciphers? Are any of my apps announcing TLS ciphers which are not secure? Am I subject to a TLS downgrade attack, or an attacker is on purpose trying to negotiate a cipher that is not secure or not as secure as it could be? We have visibility into all of that and can provide you statistics, alerts, and all of that with this visibility. That's just one example. On the networking level, on the application protocol level, we have deep visibility into all of that and can then actually export that into an SIEM. So you can obviously, we have APIs in Cilium itself, but often you want to export that into an SIEM where we have your system of record for all security relevant data. And then last but not least, we can also be an identity aware network tap. So if you want to, for example, run an IDS, you can use Cilium to filter a subset of the traffic, mirror that, and send it to an IDS for further introspection. So I wanted to deep dive quickly on this process level visibility because I think it's absolutely mind-breaking. So apologies for the bad resolution here, but this is a typical 5-tuple network flow log. I've picked an AWS flow log here, but all the cloud providers use this. All the network tooling provides this. It's this IP is talking to this IP, and this is the number of bytes that have been transferred. That's the number of packets that have been transmitted. Nice, right? But what does that mean if you're running containers? Containers are reusing IPs within seconds. So all of these logs become meaningless. Can you tell, looking at an IP address, what container, what service this was? Probably not. So what do you want? You want something that gives you the Kubernetes metadata. You want to see the service name. You want to see the namespace. But you want to see more than that. You want to see the entire process ancestry tree. Who started this container? What process inside the container is causing this traffic? You want to see whether it is the sidecar proxy or the actual workload. You want to see whether it is an application developer running kube control exec, running a bash in the pod and just debugging something and then by accident causing some network traffic. You want to see this difference. And in order to see this difference, you need to have understanding of the process ancestry tree. And on the right, we're actually seeing the network traffic. Where does it go out to? And again, you're seeing no IP addresses there. You're seeing DNS names. So Cilium has DNS visibility that is able to extract all the DNS names. And this is not reverse lookup. This is introspecting the DNS handshakes. So it's actually learning the communication with the DNS server. If you look at this example, like, take a guess. What does this example show? I'm not sure whether the screen is actually big enough for you to see it. Probably not. So this is a perfect example of a lateral attack. We have an application that is running. In this case, it's a node application. The binary name is crawler. And then we see netcat being invoked, like NC, netcat being invoked to create a connection outside to the name gibberish, not eververshell.com, not suspicious at all, of course. And then we see another bash and then a curl command invoked. So this is a very typical example of workload gets compromised, reaches out, because the firewall will block everything from coming from outside. So the pod will reach out. And then through that outgoing connection, the attacker will create a new shell and start actually exploring. In a network flow-based model, you would never ever see this. You will just see IPs talking to each other. And worst case, these IPs are supposed to be talking to each other, so even the network policy will not catch this. Let's look a bit into the API-aware authorization, right? When we talk about doing segmentation with Cilium, we can do a variety of things. We can do, obviously, layer 3 segmentation. What pods can talk to each other? We can, of course, understand ports, right? Yes, this pod can talk to this other pod, and it can do so on port 80 or on port 443. But then we can go further and actually understand protocols such as HTTP, Kafka, Cassandra, and so on, an ever-expanding list of protocols, and we can lock this down as well. So you can write a rule and say, yes, this pod can talk to this pod, but you can only do an HTTP get to /foo. You cannot do a post, you cannot do a patch. You can only do a get. Or you can access this Cassandra database, but you can only do a select on this table. You cannot do an insert, you cannot write to it. Or this pod can talk to the Kafka cluster, which is multi-tenant, but you can only produce to this topic. You cannot consume, right, to this specific topic. This is allowing you to do segmentation on the next level. And in terms of microservices, everything is using REST. So doing port-based segmentation is almost meaningless because every single application is talking on port 80 or 443. You really need that application awareness. And with Cilium and with BPF, we can help you there as well. The next good example, I think this is actually probably most used security feature in Cilium, is the DNS awareness. So how many of you have been in a position where you had to secure a cloud-native workload talking to an API that is outside of the cluster? This could be a cloud provider-based data center, data store service, for example, AWS S3, or an application pod talking to api.twitter.com. How many of you were in a position where you had to secure this? How do you secure this? It's incredibly difficult. If you look at, for example, AWS S3, it's backed by hundreds and hundreds of IP addresses, constantly changing. Like, how do you build a firewall to secure this? It's challenging. You need to, what is the static identifier in that? It's only really the DNS name or the SNI in the TLS handshake. We have chosen to utilize DNS. So I've included an example here where you can write a policy that basically said, hey, my pod needs to talk to startup.mydomain.io. Obviously, this could be anything. And then Cilium will do enforcement on two sides. It first of all will only allow DNS requests matching this pattern. So if the application pod is trying to, I don't know, look up google.com, that will fail. And then Cilium will observe the actual replies from the DNS server and only allow the IPs that have been returned. So in the case of something like AWS S3, even though theoretically it might expand to hundreds and hundreds of IPs, in practice it will only allow the 4 IPs that are returned by the actual DNS server. And that's really least privilege security. This is in particular important as well because you will have many, for example, if a website is behind some, like for example, a CDN, you will have lots and lots of IPs constantly being reused for many different purposes. So you're really interested in locking down the number of IPs that are actually allowed. So the last piece here, the last big use case is observability. And all of our observability is built in a way to build self-service visibility for teams. And team is actually pretty broad here. It could be the platform team trying to extract troubleshooting data or dashboards. Is my cluster healthy? It could also be security teams. Are any of my security rules being violated right now? Or it can be application teams that have an intent or a desire to monitor applications. What's important with Cilium and Hubble, and we'll show we'll look at an example of Hubble. We can not only see everything, we can then scope it down and provide the data or the visibility to the team only to the extent that they should see it. A typical example is you have a team that is deploying into 1 or 2 namespaces in a cluster. You don't want to have for that team to see the entire cluster, like the visibility of all of the cluster. You want to lock it down and only give them the visibility to see traffic and violations for the namespace they are responsible for. Overall, we have 3 kind of high-level buckets that we provide here. One is the service map. It's an overall graphical overview. What are the services that are running? Like what are the pods? What are the containers that are running? And what is the communication between them and to the outside and from the outside in as well? The second big bucket is metrics and flows. So we can provide metrics using Prometheus and in the next release OpenTelemetry. That is connecting back to the open tracing world. So metrics and flow logs. What are the network traffic that was ongoing? How many policy violations have happened? How many DNS failures are currently happening? Which pods are currently subject to DNS failures and so on? And then the last piece on the right is the network policy editor, giving you visualization of what are the network policies, what are the network security rules that are currently loaded. So let's take a kind of a zoom in on the Hubble observability data here. I think what's really fascinating about eBPF is that it's able to see everything transparently. So it does not require injection of a sidecar. It does not require for applications to change, but we can still see everything both from a networking perspective, what are the packets flowing, but also from an application protocol perspective, which means we can actually provide a graph. What is the communication? Even on the function level, what are the HTTP calls? What are the gRPC calls that applications are making? We can do so transparently. So you can deploy this into your cluster, and minutes later, you get back this observability, and the applications don't even know that this is around. And then you can, in turn, create a self-service portal to expose this visibility back to the end users. And the application teams will love you because you give them a transparent way to know when their application starts failing, because the application will typically, for example, return HTTP 500 codes. It's visible in this dashboard. Obviously, all of this is great, but it has to work, in particular in the cloud-native example, it has to work at scale. Liz talked a little bit about the performance side. I think that's important as well. In the next slide, we'll see some of our users from telcos to financials and so on. It's important to cover everything. It has to be low overhead. It has to be fast, but it also has to scale. And scale doesn't necessarily just mean number of nodes or number of services. It also means churn. It also means complexity of environments. If you're running a multi-cloud strategy and you have clusters across multiple cloud providers, it's actually pretty challenging to have network policy across all of them. Cilium has been built for this age. It's a project that has been designed and created exactly for this upcoming age of containers, so it's not struggling. We have 2 blog posts reference here that show you kind of the measured data we have. I think the biggest cluster is actually no longer 100,000 pods, but about 250,000 pods that we have measured. So Cilium adoption, pretty wide. It's actually not tailored to one specific vertical. Obviously, lots of financials are using us. I think a prominent one in Switzerland is, for example, Post Finance, an awesome team to work with. Usually the sensitive workloads come in here, but then we have data analytics platforms, we have various telcos, we have big SaaS companies that need us for the scale and so on. So I think pretty wide. In addition to the end users, we also have several cloud providers using us. The most prominent one is Google Cloud, using Cilium as the networking, network security, and visibility layer in all of their managed Kubernetes platforms. So that's GKE in the cloud and Anthos on-prem. We have other cloud providers using us as well in a variety of forms. Obviously, for the cloud providers where we are not involved or integrated directly or natively, you can still deploy Cilium, of course. You just follow the standard installation procedure. And with that, I would like to thank all of you for attending today. If you want to learn more about Cilium, Isovalent, or eBPF, I've included all the links here. Again, Isovalent is the company. If you're planning to use Cilium, talk to us. We have a Cilium enterprise distribution, which might be very interesting for you if extended EOL, hardened distribution, customer support, professional services, everything you want to, of course, also training together with Puzzle. Cilium, that's the open source project homepage. Cilium.io, and then eBPF, eBPF.io. That is the eBPF Foundation home. If you want to learn more about eBPF, low-level tutorials, documentation, videos, that's the place to go. So thank you very much, and I will give it back to Phil.
Thank you so much, Thomas. So we will start with the Q&A. Oh. Priyanka? So Tobias has a microphone. Please raise your hand if you have a question. You're not allowed to hold the microphone because of the pandemic. So please leave it in his hands. And you on YouTube, please start to write your questions. Who has a...
Hi, I have a question for Priyanka. First, thank you for your presentation. I love the CNCF, it's really awesome. You've talked about the exponential growth that you have been seeing since the pandemic and your plans for the next 5 years. And at the same time, you talked about your education efforts at CNCF. I was wondering if, considering the growth, you had considered perhaps staging up the education side with, I don't know, opening a school or something.
Sorry, so thank you for your kind words. Your question is if we are going to open a school? Awesome. Well, you know, that's not exactly a school, but the work that we do with the Linux Foundation training, with these courses that we are creating, are very much aimed at creating a set of curriculum that will help people ramp up on cloud native, right? And I think I was mentioning the certifications that we offer to and asking if folks have taken those, because I think those are a really good start. And they're not the end-all be-all, because as we are seeing needs in the ecosystem, we're adding certifications for different audiences. So I'm not going to say the details because it's like an announcement that's going to come soon. But there's a potentially maybe going to be an exam someday about for folks who are like earlier on in their journeys, right? And then they have like all this to build up to like the CEK, CCAD, CKSS. So the approach we are taking is certification based, where that's our sort of North Star. Like you study however you want, you take all the training courses, you can work with Kubernetes training providers or someone else, or study on your own, and then pass this cert to just showcase your knowledge. And part of the reason for doing that is because everyone learns so differently that you don't want to mandate a certain way of going about learning about cloud native. But yes, your point is very correct that a lot of people need support with building their skill sets in cloud native, and with the certifications at the helm, and then like courses that we add on, either to teach directly about the material in the certification, or also like we also do one-offs. Like for example, we have a service mesh fundamentals course. We would be totally happy to do more stuff on the eBPF side as well. And those kinds of like modular educational materials, I think are really helpful for, hey, I know the baseline, but I want to like add on a little bit here, add on a little bit there. So that's kind of what we've been doing right now. And the goal is absolutely to 10x the footprint of the people. It's about 100,000 folks in that certifications realm right now. But the goal is to 10x that footprint so that millions of people have learned and gone through the work. And if you have any suggestions for courses, certifications, stuff you'd like to see, please hit me up.
Can you imagine 1 million people who know how to operate Kubernetes? That's
I know, that's pretty crazy.
Pretty good.
Hey, Priyanka, thanks for being here. And Liz, of course, the question is on CNCF. I'm looking at you both on this. If we move forward in time, like 5 years, and your vision is somehow close to getting complete of a 5-year vision, where would you see the CNCF? This is the first part. And second part is, the more we move to cloud native, the more bigger role the hyperscalers take, and they become distribution and basically the incubation platform for these technologies. What kind of motivation and contribution could we see in the future from them?
Do you want to go first?
So I think in terms of where we're going to go technology-wise, if you imagine Kubernetes is sort of, the central core of the kind of cloud-native world, and I think we've seen a lot of innovation sort of surrounding that core, things like Cilium taking it kind of down and closer to the metal in many ways, with things like eBPF, and we think about eBPF being kernel technology. One of the biggest gaps, I would say, is more sort of above that. There's a huge amount to do in terms of developer experience, making it easy to write and deploy applications, and then along with that, things like making it easy to observe and secure applications, where eBPF has a role to play there as well, which is one of the reasons why I'm so excited about it. So yeah, when I think about where we're seeing lots of interest, some of it is in those kind of low-level things like WASM you mentioned. There's a lot of projects around that, and a lot in that kind of application delivery, application development. It's a huge sector, I would say.
Yeah.
I feel like there was another part of the question that I've
I can repeat. Actually, the questions, technology is one part. The second part is CNCF and its role in the future.
Right.
But the real second part is about the hyperscalers and their impact on the cloud-native technology space and CNCF.
Shall I have a go at that one as well? That part?
sure.
Yeah. So I think a really important part of this is that there's an ecosystem around CNCF. That the incumbent cloud providers are playing a massive role, and they're very engaged in the community as it is. And Kubernetes originally came out of Google, and Amazon and Microsoft and Alibaba Cloud are doing a ton, and probably some other clouds that I've forgotten. But I think it can't just be about that. It has to be a successful ecosystem where the CNCF can enable startups and service providers and training partners, and there's 90-something, I guess, Kubernetes distributions that presumably most of those are successful. So, there's a lot of scope for the CNCF to help bring the end users, who at the end of the day are often going to be paying for services and commercial support and commercial features, to bring that together to the innovative companies who can provide that. And innovation is happening in the cloud providers, the giants, and it's happening in the startups.
Absolutely. Yeah. And, to your point about what happens in 5 years, if we're now actually 5 years in to the CNCF journey. And my personal experience is that from where we were to now, we've completely reinvented ourselves. We've kept that core of starting with the Kubernetes starting with Kubernetes, then the ecosystem around it. And I think that has been one of our biggest strengths, is this ability to reinvent ourselves. And so the slide that I had around, what is the game plan for the next 3 to 5 years, it's about, it's about containers and beyond. And that and beyond is really critical point to note, because our end goal is always just help people ship fast, reliably, make technology, create the human experience that we all wanted to do, right? That's what we're trying to get at. And CNCF so far, especially with the TOC, the way it's behaved over the years, has successfully reinvented itself to keep the attention of what I say is the cloud native X professional, the cloud native developer, whatever project they may be focused on. And I think that will continue, and the shape it takes looks different, right? Like today we're talking really cool stuff with eBPF, with Cilium, and then with the developer experience, we're going to see more and more things, like the Backstage project that came out of Spotify is a really cool example. And I think that's the best part about CNCF is this community, because you all reinvent and we stay here to support and magnify. So I think that trend will continue. There will be greater maturity on Kubernetes specifically, definitely. More verticalization. We already are looking so much into it with the telcos, with the edge, with automotive, et cetera, et cetera. So I think that's the direction we are going in. More maturity, but also constant reinvention, if, we all have anything to do with it. In terms of the cloud providers, I think Liz made the key point that this is an ecosystem that includes them, and they're a very important part of it, but they also have these other different types. There's startups, there's end users, all these individual contributors, all these people are equally weighty, and actually I think that has created this unique situation where, in my opinion, at least my conversations with the clouds is they're all in. They're they're doing they're working with the CNCF paradigm very, very successfully, I think. And I think that will continue very much because of how the empowerment that we've done with the end user ecosystem. These are their customers, right? And they are here directly asking for things, giving feedback. And those folks are, by the way, represented on the board, they're represented TOC, they're represented everywhere. And so one of my top priorities is getting more and more of those folks in, making that voice bigger and bigger, because that ensures that CNCF is the center of innovation.
I've got a question for Thomas. So how do you see the relationship between the eBPF Foundation and the CNCF Foundation grow and evolve? I mean, friends, of course, but Cilium is applying into the CNCF. How do you see it growing?
Yeah, I'm looking forward, as a Cilium maintainer, I'm looking forward to, hopefully in a couple of weeks, be within the CNCF and work together with Priyanka. And I think as governing board chair of the eBPF Foundation, I'm looking to work together with the wider industry outside of the CNCF as well. There is no competition in any way at all, right? There's many other Linux foundations or foundations inside of Linux Foundation as well. That's perfectly normal. I think what's important is to agree on a charter and then go into the same direction together with everybody who's part of that foundation. So I'm looking forward to collaborate with the CNCF in any way possible. For Cilium, CNCF is definitely the best fit for sure.
And we collaborate with foundations in LF and outside of LF. It's par for course. And so having eBPF as an LF foundation just makes it that much easier. And it's very much we have established way, we've done this before with a bunch of other sub foundations. And so this is just the perfect way to move forward from my perspective.
I think also pointing out that eBPF is not purely cloud native. There are other applications of eBPF that are not cloud native, and that would be one good reason to keep. We want to enable the eBPF innovation to happen in all other spheres as well. It shouldn't be limited to CNCF. So having collaborative foundations makes a lot of sense.
And Cilium is also not the only cloud-native project that has ties into eBPF Foundation. Another good example is Falco. And as an eBPF Foundation, we welcome all projects. If you want to list yourself on the list of eBPF projects as part of the eBPF Foundation, the rules to do so are very clear, and that's open to both CNCF projects and non-CNCF projects, for sure.
Yeah, it's a simple PR, right? I saw that. It's really great.
Yeah.
People can just show up and self-declare.
Yeah, and there's a definition of what we expect.
Super awesome.
As long as it's open source, as long as it uses eBPF as the major underlying technology, you cannot just claim to be eBPF powered. You actually need to prove by code that you're actually using eBPF. I think there was another question over there, yes.
Yeah, so within the CNCF list of projects, there's a lot of overlap. For example, I want a service mesh. There's Linkerd, Istio, and now Cilium, which seems to be the future. Do you think it's the CNCF's role to give guidance on what to use here? Would you go and recommend that people invest time in Istio, for example? I mean, how do you sort of resolve these overlapping areas within the technical projects that you're supporting?
Linkerd, yes, definitely part of CNCF. Istio is in its own world. It's a great project, of course, but not part of CNCF. But yes, you're absolutely right that there's overlap. And that's because we are not intending to be kingmakers, as they call it, where you anoint one project and that's it. That does lead to the question in the community, okay, like, what do I do? And that's where I think the work that folks in, we used to have this thing called the Cloud Native Trail Map. And which is the whole idea was to help people through a guided path of like, if this, then that, then move on to this, that kind of thing. We're working on a reimagined version of that in the cartographers group that I think I mentioned, who are trying to demystify the landscape. Because this question from you, we hear it definitely that, okay, like, what's the guidance? And ultimately, because we are not playing kingmaker, we will not be telling you use this over that. However, there's going to be ample documentation, blog posts, all sorts of things on, hey, I did this use case with Linkerd and it was amazing. I did this other use case with Cilium and it was great. And so with those examples out there, and for end users, they have those developer experience private meetings where they can like talk about, oh, I did this and this happened. Those types of sort of community-based conversations are how I see people guiding themselves forward. And then this reimagining that's coming with cartographers, hopefully that'll help too.
I think another great source is always just to go to KubeCon and listen to the end users, right? In the end, it's never a foundation that decides, it's always the end user, right?
Exactly.
First of all, thanks for your talks to all three of you. I have a question related to eBPF. So both you, Liz and Thomas, mentioned networking, security, and observability as three major use cases. Do you see any other, maybe future use cases for eBPF where eBPF could really shine? And yeah.
Do you want to take it or should I?
I could start with one, but I think that, I mean, it's kind of related to security, but that idea of being able to patch the kernel dynamically is, I think it has functionality. I mean, it's that cartoon that Thomas showed, you know, the ability to add functionality or to patch vulnerability or mitigate, patch in inverted commas, vulnerabilities dynamically. I think that's a huge other use case.
Yeah, I think that's the one I would have mentioned as well. It's kind of this misbelief that kernel developers only write perfect code. Can assure you that's not the case. There are bugs in the kernel introduced. So the concept of potentially not writing kernel code that potentially crashes, but instead write eBPF code that is subject to a sandbox is very appealing. I think in particular in a world where a single mistake in kernel logic can cause an entire data center to go down, right? I think perfect examples of this have been a couple of bugs in the TCP and UDP layer where a remote packet could cause a kernel to crash. Knowing this flaw, you could literally crash an entire data center of one of the hyperscalers which is mentioned. And that is a big risk, and one of the ways to mitigate that is by leveraging eBPF, not just from a dynamic loading perspective, but as an additional safety measure instead of writing kernel code natively. There are many, many more. I think there are even some wild use cases out there. I think I've seen eBPF being seen to implement entire ciphers to do encryption, for example, where the Linux kernel did not support a particular cipher, but it was needed for compliance reasons. eBPF gave the chance to do so. I think there is also an entire applicability in terms of IoT devices, where a lot of specific requirements and small logic pieces are needed on embedded systems. And it's not something I covered at all in my talks, but eBPF has a very, very low footprint. Actually, Liz had this perfect slide, right? I remember the flame graph, and the eBPF portion of it was very, very small. And why was that? Because we were able to bypass huge portions of the Linux kernel. And if you talk to somebody in the embedded Linux world, all they ever care about is reducing the footprint. Less code, like it has to be smaller, smaller, smaller. eBPF will definitely play a role there as well.
I have a weird vision of like a very, 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 very small Linux that might even not be called Linux anymore, that is essentially just like a framework for eBPF. And
are you saying that the Linux will become a microkernel eventually?
More questions?
Thank you. I have two questions, actually. One is probably for Thomas and Liz. It's about eBPF, if you mind or are able to share a bit how it came to be or how its use developed, because I have not researched too much about it, I confess, but by the name and its uses, I had assumed that it was something created in the 70s that recently became really useful. So I was a bit, if you can share.
There's a funny story around that. So eBPF does share the name with BPF, and BPF has BSD roots, and it comes from the 70s, so it's older than many of us, or almost everybody in here. And I think if you look at eBPF today, it's actually something completely different, but it's capable of running the old flavor, which is a lot more limited. Like this classic or this original BPF, it's a lot more limited than what eBPF can do today, but it's capable to run this. And the reason for this is when eBPF was proposed, it was made a requirement that, hey, the kernel community does not want to maintain yet another byte language, yet another virtual machine. Please make it compatible to something that already exists, which BPF was one example of this, so we don't have to maintain one more. So that's where the name comes from. The reason why eBPF exists is that at some point, exactly 7 years ago, there were discussions around, hey, we need observability in the kernel. And some people wanted that, and others were not willing to pay the cost of having that visibility. So like, let's increment the counter here, and let's increment the counter there. I need to know when this is happening. And for every event, for every counter that was incremented, everybody else using the kernel would pay the cost. So the Android phone would pay the same cost as a Linux kernel running in a big data center. And that was kind of the birth of eBPF. Let's make it programmable so we don't have to agree on every single change. Hence kind of the idea of it, and then the name is really just from that compatibility perspective.
Okay. The second one is for Priyanka. It's about the community part, well, not the community part, sorry. I'm wondering if the foundation keeps track or tries to, cannot find the word now, sorry. What part of development or work in the foundation's project happens by volunteers, by people that do not have a job for doing that? Like, what's the weight of that? If it is a pursuit that the foundation wants to, I cannot find the word in English right now. Like, care for that, sorry.
Yeah, if I understand correctly, you're asking what group percentage of contributors are doing it on their own time versus people who are paid to work on CNCF projects. Is that right? So while I don't have an answer to that, what we do have publicly available is stats on the company affiliation of all the contributors that we have for various projects. So you can see, for example, I'm just making this up, like Apple has X number of folks, Isovalent has Y number of folks, Google, and so you get the company affiliations of folks. Beyond that, how many of those are like, it's their day job to do this versus they just like to do this, that is not tracked. And I think my personal opinion is that both types of contributions are super valuable and valid. And the reason is, one is that when you have companies actually paying people to work on open source, it's obvious that they're doing it because those projects are critical to their products and services and thereby revenue generation. So that gives like a longevity, I think, to the project. The individual contributions that come on people's own time are also very important because they can be a sign of personal development, someone growing their career, things like that. Because of this like healthy mix that exists now, though, someone could take a personal interest and get started contributing, and it'll be very acceptable by most employers. And they might be able to then like morph into a role where it's a paid opportunity, etc. So both types of contributors exist, and I think it's really healthy that because of that, contributing to open source in general has become that much more accessible for people working at different jobs.
I think it has been a massive career opportunity for many to actually,
Yes.
let's say, you come out of university, work on a cloud native project for a couple of months, and typically you will get
Yes.
hired. So I think cloud native in general has been a huge career boost for
Definitely.
many people, and also has made the job market a lot more accessible as well. You can prove your skills with code contributions. That will be speaks louder than any CV ever could.
Totally. We do a lot of like we participate in Google Summer of Code. We do LFX mentorships year round for folks who want to be part of our projects. And those are those like accessibility options to help people come in who may otherwise not have the opportunity. And actually at my KubeCon EU keynote, I was able to invite this person. His name is Mrityunjay, who is a student in India. And the only reason he is now such an avid contributor in Kubernetes and in the ecosystem is because he got, first he got a scholarship to attend Open Source Summit. That was his step one. And he didn't ask anyone. He didn't get approval from university or anything for that. And then from there, he got into Google Summer of Code, if I remember correctly, as well as LFX mentoring. And those opportunities, because they also give a stipend, were able to help him. Now he's involved in all sorts of conversations, and from what I hear, he's getting popular amongst potential employers. And he's just one example of many who have done that. So there are all those avenues available to go from hobbyist or interested party to paid to work on this.
More questions? Okay. One. Last one.
I actually have one question that got triggered by the previous question. Does the CNCF has any initiative to prevent or mitigate issues in open source projects? When, for example, I remember a few years back in OpenSSL, there was the Heartbleed attack. And if something like that happens in any CNCF project, how do we do? What do we do?
Yeah, I'll share my perspective real quick, and then would love for you to as well. So two-pronged approach. One is that for all graduated projects, we do the security audits, right? And that's an essential thing you have to pass to be a graduated project, and I think that helps us a lot. And on that one, it's not just that we do one type of security audit and we've been doing that for 5 years. Absolutely not. We have evolved in the ways we are doing the security audits. We're also doing fuzzing now, for example. We're talking to the OpenSSF to do a collaboration with them to try out new ways to basically get more and more coverage and understanding of our graduated projects. So that's one piece, one line of attack. The second piece is really relying on the community to, I think there's so many of you and so few of us. And so it's it's a collaborative effort where people raise issues as they come up. And so it's proactive with the audits and reactive with just responding quickly when you hear something. Liz, do you want to add?
Yeah, Tag Security, the technical advisory group, who are, I would say, the most active of the tags, and there are about 7 or 8 of them. I can't count in my head. But yeah, Tag Security have a ton of really good initiatives. They'll do things like having a security buddy for a project to help a project, because not every project has somebody involved on a day-to-day basis who's particularly interested in security, but they'll pair up with a security buddy who maybe wants to get more experience or renown or reputation, but who knows something about security and can help that project think about what concerns they might have to address from a security perspective. They also have a kind of security assessment process where it's much more informal than the kind of audit that we require at graduation, but the assessment process can help, particularly an incubating project, to figure out what might be weak areas, what things they might want to look at in more detail. It's certainly something that over the time that I've been involved in the CNCF, it's gone from really security is kind of well, we just sort of assume that it's all going to be taken care of, to something that actually there are now sort of processes in place, and also the dependencies. There's some initiatives in the in kind of at the Linux Foundation level for helping,
dependency scanning.
Exactly, for scanning the potential vulnerabilities across all the projects. I think the other aspect to this, and particularly thinking about OpenSSL, is making sure that there are maintainers for projects. Because as I understand it, one of the problems with Heartbleed was the people who wrote the code were, I don't know, retired, dead, I don't know, and not necessarily able to, it wasn't like an easy fix. And my understanding is there was quite a kind of scurrying around of trying to find people who were expert enough to fix it. One of the things we tried to do, particularly with graduated projects, is make sure that there's a healthy maintainer community, so that we're not supporting projects that where, you know, no project is static, and there need to be things like a security team or a contact point for raising security issues, and you know, we expect there to be maintainers who will take it seriously. We not just expect, we require there will be maintainers who will take it seriously for a graduated project. Vulnerabilities will happen, we can't exclude that, but we, for a graduated project, expect there to be processes in place to address them.
Okay, so the speakers will be available at the apero later on, so if you go out to this kind of food truck, there will be drinks. So with this tag, you'll get free drinks. Make sure you get some swag when you go out. And once again, thanks to Puzzle ITC for helping in organizing this event. We couldn't ask for a better partner here in Switzerland. Thanks.
Let me put my stickers out really quickly.